Hi students, welcome to physics classes. Today we will discuss electric current. Chapter electric current. Now in 19th century scientists Drude and Lorentz did some experiments and they explained about electric current. Conductor consists of large number of free electrons. Large number of free electrons. Conductor consists of large number of free electrons. Conductor means which allows the electric current to flow through them. The material which allows electric current to flow through them. Or conductor. Allows electric current means it is having electrons. Electrons are the main important thing to flow electric current. Now here conductor consists of large number of free electrons. Why we are saying large number of free electrons? Large number of, there are more electrons will be present in the conductor. Free means they are able to move freely in the conductor. They are able to move freely in the conductor. Now electrons, free electrons. Conductor consists of large number of free electrons and it is having positive ions. Positive ions. And these positive ions are fixed in their locations. Positive ions fixed in their locations is known as lattice. Fixing of positive ions. Positive ions are fixed, they won't move. Only electrons will move. That's why free electrons, free to move in a conductor. Positive ions will not move from its position. That is lattice, fixing of positive ions. Now here electrons are moving in their own direction. See here, no direction. One is going up, one is coming down, one is going straight, one is coming down. Like that they are moving. No fixed direction. Their own direction they are moving. When it is in the open circuit, means not connected to the battery, not connected to the source. This is known as random motion of the electrons. Random motion of electrons means no specified direction. No specified direction. Now here, if you consider this is point A, this is point B. If you consider any cross section, here there is no fixed direction, either moving forward or coming backward. No fixed direction. If you consider these 2 points A and B and this is cross section. Now number of charges crossing this cross section from A to B is equal to B to A. So whatever it is coming from A to B is equal to B to A. So we can say that no net charge or net charge equal to 0. Net charge is equal to 0. Conductor consists of large number of free electrons, while the positive ions are fixed in their position, that is known as lattice. Here when it is in the open circuit, they will move randomly in the conductors. They means electrons will move randomly in the conductors, that is known as random motion of electrons. Now if you consider any cross section and point A and B, number of charges crossing this cross section from A to B is equal to B to A, then we can say no net charge. Net charge equal to 0. If the same conductor is connected to the battery source. Now when it is connected to the battery, or any cell, any source, then that source provides electric field throughout the conductor. Then electric field makes the charges, electrons, to move in specified direction. Specified direction, they will move in a particular direction, specified or particular direction. That moving of electrons in a specified or particular direction is known as ordered motion of electrons. Ordered motion of electrons. Now here, if you consider again, this point is A, this point is B, this is one cross section. Now here the number of charges crossing this cross section from A to B is not equal to B to A. From A to B is not equal to B to A. So there is some net charge. How much it is? We can't say. Some net charge is there. Here, when the conductor is in a circuit connected to the source, either battery, cell, or any source, then electric field set up throughout the conductor. That electric field makes the electrons to move in specified direction. That moving of electrons in specified direction is known as ordered motion of electrons. Now if you consider A and B, one cross section, number of charges crossing this cross section from A to B is not equal to B to A. So we can say some net charge is there. Now from that we can write the definition of electric current. Now there charge is crossing the cross section. Now amount of charge crossing any cross section in 1 second or unit time is known as electric current. Amount of charge crossing any cross section in unit time is known as electric current. Now electric current is denoted by letter I, charge denoted by letter Q, time denoted by letter T. Now electric current I equal to amount of charge per unit time, Q by T. Electric current equal to electric charge divided by time taken. Now SI unit of electric current is ampere. As ampere is a scientist name, while writing symbol we should write A, while writing completely we should write ampere, A with small alphabet. Q. SI unit of Q is coulombs. SI unit of Q is coulombs. Time we know second. Time we know that is second. Then 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. This is about electric current. Amount of charge crossing any cross section in 1 second or in unit time is known as electric current. Electric current is denoted by letter I, charge is denoted by letter Q, time is denoted by letter T. I equal to Q by T. SI unit, I means electric current, SI unit ampere, Q, SI unit coulomb, charge SI unit is coulomb. Now 1 ampere equal to 1 coulomb per 1 second. Now when the conductor is in open circuit, electrons are able to move freely. When they are moving, they will get collision with lattice ions. During collision, the electron will loses its sum of energy. Its sum of energy, and sometimes it will loses its total energy. So it may come to rest. It may come to rest or halt. Rest or halt. Now when it is connected to the source, here also when they are moving, it will get collision with lattice ions. In that situation, it will lose some of its energy, and that energy again gained by electric field. Here in open circuit, it is losing energy, but nobody are giving its energy back. Nobody are giving its energy back. But in the closed circuit, when the connector is connected to the source, that source electric field is giving that energy. Whatever it lost, that energy again electric field will be gives. Then it will move in a specified direction. Now whenever the conductor is connected to the source, electrons on the conductor, electric field is set up throughout the conductor. And that electric field makes the electrons to move in specified direction. Now here also, while they are moving, they will get collision with lattice ions. Whenever it is getting collision with lattice ion, it will loses its energy, either sum of energy or total energy. But electric field again gives its energy back. Electric field gives the necessary energy whatever it requires. Then while during collision, its direction will be changes. And again electric field gives the energy and makes it to move in specific direction. Again it will get collision, loses energy, and electric field gives the energy and it will move. Like that, for each collision, it loses the energy, and whatever it lose, that energy again gained by electric field. And during the collision, it is changing its direction. And whenever it changes its direction, electric field again makes it to move in specified direction. So it will start from one point and reaches the another point. Now it will move with a speed that is known as drift speed. Or drift velocity. Drift speed or drift velocity. Now it is not having constant velocity. each time its velocity will be changes. That we will take average velocity or average speed. Average velocity or average speed. Now electron will move with average the total from starting to ending, it will travel with different speeds. That's average we will take. That's average we will take. The average speed of the electron to move from one point to another point is known as drift speed. Is known as drift speed. It is denoted with Vd. Denoted with Vd. Vd means drift speed. Now we will take a conductor. We will consider a cross-sectional volume. We will take cross-sectional volume. This one, cross-sectional volume. This area is A. Area is A and drift speed Vd. Drift speed Vd. Cross-sectional area, whatever we are taking, that is A. And electrons drift speed is Vd. Now time taken to cross this cross section. Time taken to cross this cross section will take 1 second. Will take 1 second. Now speed is Vd. Time is 1 second. Can we take distance by time? Vd. Drift speed equal to distance by time. As time is 1 second, we can take distance also Vd. When time is 1 second, distance equal to Vd. Then we can consider volume. Volume, what we consider? Area into this distance. Area into Vd. Now total number of charges in this volume is NAVD. Then total amount of charge is NQAVD. Each charge Q. In that volume, NQAVD. Now this charge is crossing this cross section in a time t. Then I equal to Q by T. Electric current equal to charge by time. Q, number total charge, NQAVD by time t, that is equal to 1 second. Then I equal to NQAVD. Vd means drift speed. Vd means drift speed. If you write Vd equal to NQA coming this side divided by Vd equal to by NQA. This is the formula to find drift speed. Now we'll discuss potential difference. Now we have seen whenever electric force is acting on the electrons to move in specified direction. Electric force acting on the electrons to move in specified direction. Now whenever there is a force acting on any object, it causes displacement. Force acting on any object, it causes displacement. We can say work is done here. Work is done. Now here on the electrons, electric force is acting. On the electrons, electric force acting. That electric force makes the electrons to move from one point to another point through the distance L. Then we can say electric force is doing some work. Electric force is doing some work. We can define like this. Work done by electric force. Work done by electric force on unit positive charge. On unit positive charge to move from A to B. To move from A to B through the distance L. Work done by the electric force. Work done by electric force on unit positive charge to move from A to B to the distance L. To the distance L is known as potential difference. Is known as potential difference. Potential difference is denoted by letter V equal to work done by charge W by Q. Work force into displacement, electric force, distance L, electric force Fe. This is Fe by Q. Fe by L by Q. Now SI unit of potential difference volt. SI unit of potential difference is 1 volt equal to work 1 joule per charge 1 coulomb. 1 volt equal to 1 joule per coulomb. Like this, we can define EMF also. Electromotive force. Electromotive force. As we discussed potential difference in the conductor, we can discuss EMF in the battery. In the battery, there will be positive terminal and negative terminal. And here negative ions will move and positive ions also will move. Here work done by the chemical force. Work done by the chemical force. Work done by chemical force on unit negative charge or unit positive charge. Positive, if it is positive charge, it is moving towards positive terminal from negative terminal. If it is negative charge, it is moving towards negative terminal from positive terminal. Now I'll tell you the definition. Work done by the chemical force. Work done by the chemical force Fc on unit positive charge to move from negative terminal to the positive terminal. Negative terminal to the positive terminal. If it is negative charge, work done by the chemical force on unit negative charge to move from positive terminal to negative terminal. Once again I'll repeat. EMF, electromotive force. As potential difference is in the conductor, EMF we can discuss in the battery. There will be electrolyte, electrodes, positive electrode, negative electrode, electrolyte. Electrolyte, it consists of positive charges, negative charges, both will move. Both of them, chemical force is acting here. Chemical force. This chemical force acts on the unit positive charge to move from negative terminal to the positive terminal. And the same chemical force acts on negative charge to move from positive terminal to the negative terminal. Work done by the chemical force on unit positive charge to move from negative terminal to the positive terminal. And work done by the chemical force on unit negative charge to move from positive terminal to the negative terminal. That is EMF. EMF equal to work done by the charge. That equal to Fc. If I take this distance is d by q. Fc d by q. Then it is equal to potential difference. We can write EMF equal to F d by q. same units. Volts, 1 joule per 1 coulomb. Thank you for watching. Please subscribe.